Hi everyone and welcome to Fat Math. In this video, we will apply the laws of logarithms to expand the logarithm and to condense sum and difference of logarithms to a single logarithm, a useful skill in solving logarithmic equations and inequalities. The logarithm of the product of x and y to the base b is equal to the sum of the logarithms of x and y. Okay, we can prove this by changing this into its exponential form. Okay, but in this video, we will only apply these laws of logarithms. Number 2, the logarithm of the quotient of x and y is equal to the logarithm of b, logarithm of x minus logarithm of y. Meaning to say, if you will expand the logarithm of a product, it will be a sum of logarithms. So if you will condense a sum of logarithms, it is going to be the logarithm of a product. For number 2, if you will expand this logarithm of a quotient, it's going to be a difference of logarithms. And if you will condense the difference of logarithms, that will be the logarithm of the quotient. And number 3, the logarithm of x raised to n to the base b is equal to n logarithm of x to the base b. So the exponent of x here, which is n, becomes the coefficient. Or if you have a coefficient here, you can make it the exponent of x. Okay, let us apply these laws of logarithms to several examples so that you will be more familiar with them. Example, expand and if possible, simplify. Logarithm of 2x to the base 2, that is the logarithm of the product of 2 and x. So if we will expand that, we will have logarithm of 2 plus logarithm of x, both to base 2. And logarithm of 2 to the base 2 can be simplified to 1. And the final answer will be 1 plus logarithm of x to the base 2. Another example, logarithm of the product of x and x plus 3 can be expressed as the sum of the logarithm of x and the logarithm of x plus 3. So the logarithm of a product is equal to the sum of the logarithms of the factors. Number 3, logarithm of x squared y to the base 2 is equal to logarithm of x squared plus logarithm of y. But applying law number 3 here, the exponent of x, which is 2, can be a numerical coefficient. So our final answer here will be 2 times the logarithm of x to the base 2 equals logarithm of y to the base 2. As what you can see, the exponent of x, which is 2, becomes the coefficient here in the final answer. Number 4, logarithm of 16 over y to the base 4, that is quotient. Logarithm of the quotient of 16 and y to the base 4 is equal to the difference of the logarithms of 16 and logarithm of and y. So logarithm of 16 to the base 4 is asking us the exponent of 4. So that the answer is 16 and that is 2. So logarithm of 16 to the base 4 is 2. Copy logarithm of y to the base 4. So our final answer is 2 minus logarithm of y to the base 4. Last example, logarithm of y plus 3 over y minus 2 to the base x is going to be logarithm of y plus 3 to the base x minus logarithm of y minus 2 to the base x. So this is expanding a single logarithm to a sum or difference of logarithms. Okay, so please answer these exercises. So we have here 5 items for your practice. Number 1, logarithm of the product of 9 and y plus 5 to the base 3. Number 2, logarithm of 8x cubed to the base 2. Number 3, ln of x squared times x plus 6. Number 4, logarithm of x plus 8 over y squared. And number 5, logarithm of 3x raised to 4 over y to the base 3. So applying the laws of logarithms, Number 1 is going to be logarithm of 9 to the base 3 plus logarithm of y plus 5 to the base 3. Logarithm of 9 to the base 3 is the exponent at which 3 should be raised to get 9. That is 2. So the final answer will be 2 plus the logarithm of y plus 5 to the base 3. Number 2, that is going to be logarithm of 8 to the base 2 plus logarithm of x cubed to the base 2. Logarithm of 8 to the base 2 is asking us the exponent at which 2 should be raised to get 8, and that is 3. So we have 3 plus the exponent of x here, which is 3, can be a numerical coefficient by applying law number 3. So that will be, the second term will be 3 logarithm of x to the base 2. Number 3, we will have logarithm of x squared plus logarithm of x plus 6. So the factors here are x squared and x plus 6. So we will have the sum of their logarithms. In this case, ln, base e. Okay, logarithm of x squared or ln of x squared can be written as 2 ln x by applying law number 3. So the final answer is 2 ln x plus ln of x plus 6. Number 4, logarithm, there's no base written, so that's base 10. Logarithm of x plus 8 over y squared. We can apply here law number 2, that the logarithm of a quotient is equal to the difference of the logarithms. So we will have logarithm of x plus 8 minus logarithm of y squared. But the exponent of y, which is 2, can be a numerical coefficient if we apply law number 3. So the final answer will be logarithm of x plus 8 minus 2 logarithm of y. And last number 5, we will have logarithm of 3x raised to 4 to the base 3 minus logarithm of y to the base 3. And the first one there, logarithm of 3x raised to 4, can be still expanded by applying law number 1. That can be logarithm of 3 to the base 3 plus logarithm of x raised to 4 to the base 3 minus logarithm of y to the base 3. And logarithm of 3 to the base 3 is 1. And then for the x raised to 4, we can make 4 the numerical coefficient. That will be 4 times logarithm of x to the base 3 and copy minus log of y to the base 3. So this skill is very important in solving logarithmic equation, or the other way around, the one that is asking you to condense. Okay, this one is expanding because sometimes you can still simplify. Okay, let's move to the second one, that is condensing to a single logarithm. So we will be given here with the sum or difference of logarithms, and then we will express as a single logarithm. Here we are given with the expanded form. We will write as a single logarithm. So we have here the sum of the logarithms of x and 4. So that will be the logarithm of their product. X times 4 is 4x. So logarithm of x to the base 3 plus logarithm of 4 to the base 3 is just equal to the logarithm of 4x to the base 3. Another example, example number 2, logarithm of 8 to the base 4 plus logarithm of 2 to the base 4. So that's, again, a sum. So we can express that as the logarithm of the product of 8 and 2. And the product of 8 and 2, 8 times 2 is 16. So logarithm of 16 to the base 4 is the exponent at which 4 should be raised to get 16. The answer is 2 because 4 squared equals 16. Number 3, 3 logarithm of x plus logarithm of y. The first term can be expressed as logarithm of x cubed because the numerical coefficient can be the exponent of the one here. So logarithm of x cubed plus logarithm of y, that is a sum of logarithms which can be expressed as the logarithm of the product of x cubed and y. And the product of x cubed and y is x cubed y. So the answer here is logarithm of x cubed y. Number 4, logarithm of x plus 3 to the base 1/2 plus logarithm of x minus 2 to the base 1/2. is a sum of logarithms, which we can write as the logarithm of the product of x plus 3 and x minus 2, and their product is x squared minus 2x plus 3x minus 6, which can be simplified to x squared plus x minus 6. So the answer is logarithm of x squared plus x minus 6 to the base 1/2. A very important skill in solving logarithmic equations and inequalities, because later on you will be given with equations wherein one side has sum or difference of logarithms, and for you to answer or to solve the equation, you need first to condense the two logarithms to a single logarithm. Okay, let us check if you know how to apply the laws of logarithms to condense to a single logarithm the given. Oh, this is still more examples. Okay, so this is not yet exercises. Here in numbers 1 to 4, these are all sum. So if these are all sum, then our answers are all logarithm of the product. In examples 5 to 8, we will have logarithms of quotients. Or I will give you first the difference of the logarithms, and that we can condense to the logarithm of the quotient. Like this: logarithm of x to the base 3 minus logarithm of 4 to the base 3. This time it's minus, so it should be the logarithm of the quotient of x and 4. So x divided by 4, we cannot simplify that further, so that will be the answer. Logarithm of x over 4 to the base 3. Number 2, logarithm of 8 to the base 4 minus logarithm of 2 to the base 4 is logarithm of 8 divided by 2 to the base 4. 8 divided by 2 is 4, so logarithm of 4 to the base 4 is 1. Number 7, 2 logarithm of y minus logarithm of y minus 1. The first term can be expressed as logarithm of y squared by applying law number 3. So logarithm of y squared minus logarithm of y minus 1 is logarithm of the quotient of y squared and y minus 1. So log of y squared over y minus 1. And last example, we have 3 logarithm of x to the base 2 minus 2 logarithm of y to the base 2. The first term can be written as logarithm of x cubed. The coefficient 3 can be the exponent here to the base 2 minus, and the coefficient 2 here can be the exponent of y. So logarithm of y squared to the base 2. And the difference of logarithms can be expressed as the quotient or the logarithm of the quotient. So the answer is logarithm of x cubed over y squared to the base 2. Okay, let us check your understanding with these 6 items. 1 to 3 includes sum of logarithms. You have to condense to a single logarithm. And numbers 4 to 6, difference of logarithms. Remember that if you have a coefficient, that can be the exponent of what's inside the logarithm. And if you have a sum of logarithms, you can express that as the logarithm of the product. And if you have a difference of logarithms, you can write it as the logarithm of the quotient. Number 1, logarithm of 27 to the base 9 plus logarithm of 3 to the base 9. We can have the logarithm of the product of 27 and 3 to the base 9. The product of 27 and 3 is 81. 27 times 3 equals 81. So logarithm of 81 to the base 9 is asking us the exponent at which 9 should be raised to get 81. So the answer is 2, because 9 squared equals 81. Number 2, we have logarithm of the product of 2x plus 1 and x minus 1. 2x times x is 2x squared. 2x times negative 1 is negative 2x. 1 times x is x, so negative 2x plus x is negative x, and 1 times negative 1 is negative 1. So we have logarithm of 2x squared minus x minus 1. So you can multiply there in your notebook if you want to try. 2x plus 1 times x minus 1 if the answer is indeed 2x squared minus x minus 1. Number 3, we can write that for logarithm of x to the base 5 as logarithm of x raised to 4 to the base 5. while the second term, 2 logarithm of y to the base 5, can be written as logarithm of y squared to the base 5. And since this is the sum of logarithms, we can write this as the logarithm of the product of x raised to 4 and y squared. So that is logarithm of x raised to 4 y squared to the base 5. Okay, don't forget your base 5 here, because they're both with base 5, base 5, base 5, base 5, base 5. So the answer should also be to the base 5. Okay, number 4, logarithm of 3x to the base x minus logarithm of x to the base 3 can be expressed as the logarithm of 3x over x to the base 3. And 3x over x is 3, so logarithm of 3 to the base 3 is 1. Number 6, ln of x plus 5 minus ln of x plus 7. Very simple. Is this a difference of logarithms? So the answer is logarithm of the quotient. So ln of x plus 5 over x plus 7. Number 6, we can write the first term as logarithm of x raised to 5. Copy the second term, logarithm of minus logarithm of y plus 1. And then, since this is a difference of logarithms, we can write this as the logarithm of the quotient of x raised to 5 over y plus 1. And that will be the final answer. Okay, who got 6? If you got 6, please comment down below. If you have some questions, you can also write there in the comment section. So that's it for laws of logarithms. Thank you so much for being with me in this video. Till next time, bye! Thank you for watching. Comment, like, and subscribe. Bye!